In the world of AI, we love to talk about how powerful these systems are. But what happens when one tiny mistake triggers an absolute catastrophe? That's what we are diving into today. A really critical vulnerability from OWASP Top 10 called cascading failures, where OWASP stands for Open Web Application Security Project. And this quote really hits home. I mean, we usually think of a system error as this little isolated thing. But when you have a whole network of AI agents all talking to each other, a single failure can make a lot of noise and the consequences can be absolutely devastating. Think about it like this. It's like falling dominoes. One single domino tipping over, who cares, right? It's pretty insignificant. But when it's lined up with thousands of others, that tiny little push can bring the whole thing crashing down. That right there, that's the core idea of a cascading failure. Okay, so let's really break this down. What exactly is a cascading failure? What are we really talking about when we use that term for AI? Here is the definition. The most important thing to get here is that the first mistake, that's not even the real problem. The real danger is what that mistake sets in motion. It's an error that doesn't get caught, it isn't contained, and it just spreads like wildfire throughout the rest of the system, getting bigger and more serious with every single step. And look, this stuff doesn't just happen by accident. It happens because how these systems are designed, or maybe I would say poorly designed. You have got agents that just blindly trust whatever data they get. You have got automation just chugging along, making a bad decision worse and worse. And the whole time, there are no checkpoints, no human in the loop to say, hey, wait a minute, before a tiny error blows up into a full blown crisis. Okay, there is one thing, but let's look at a real world story that is, well, pretty painful. We are talking about a $500,000 mistake. This isn't some abstract concept. This is a failure that had a huge, I mean, huge financial consequences. So let me paint you a picture. Imagine a pretty standard automated payment system. You have got one agent, an OCR agent, that reads incoming invoices. Then an accounting agent takes that data and pays the bills. A reporting agent logs everything, and finally, an auditor agent checks for anything weird. Sounds super efficient, right? Cool. But what happens when all these agents are just blindly trusting each other? Yeah, this is what happens. $500,000 gone. All because of one tiny little misread on a single invoice. Just a tiny glitch in that very first step. So let's walk through exactly how this disaster unfolded. Okay, here is the play by play. And what's so scary is how normal it all looked. First, an attacker sends a doctored invoice, maybe with some weird formatting to mess up with the OCR. The OCR agent reads it and messes up, turning $5,000 into $500,000. Oops. Then the payment agent, not questioning a thing, just pays the massively inflated amount. The reporting agent logs it like any other transaction. And finally, the auditor agent looks at the report, trusts it completely, and sees nothing wrong. Just like that, one tiny error and the whole system failed. And this code just nails it. Every downstream agent trusted the previous one. That's the whole problem in a nutshell. None of these agents were bad. The system just fell apart because it was built on this foundation, of absolute blind trust. So that was a finance example. But don't think for a second that this is just about money. No way. This same pattern of failure is a threat in pretty much any system where you have these autonomous agents working together. I mean, look at these other examples from OWASP. A planning agent gets a task wrong and boom, you have deployed the wrong infrastructure. A RAG agent pulls in some bad information and your code agent writes a vulnerable patch. A cleanup agent deletes something critical and your whole analytics pipeline collapses. Or how about this one? A supply chain agent grabs a bad package and a DevOps agent just pushes it right into production. The details are different, but the pattern is exactly the same. A small manageable error that spirals out of control. So you have to ask yourself, What is this that makes this so incredibly dangerous? Well, it's because automation is a double-edged sword. It scales up good decisions, but it scales up bad ones just as fast. So a tiny error can have this huge impact. The problem spreads completely silently, just hopping from agent to agent with no alarms going off. By the time you even notice something's wrong, it's a total mess and it's a nightmare to fix. And maybe the scariest part, a hacker can hide their attack right inside what looks like normal operations because the system just isn't designed to be suspicious. Okay, so we have seen the problem. We have seen how bad it can get. So now for the important part. How do we stop it? How can we build systems that can't be taken down by a single domino? The solution is actually to add a little bit of what OWASP calls as good friction. Instead of blind trust, you build in validation checkpoints. Instead of unchecked automation, you require a human to sign off on big decisions. To stop that silent spread, you actively monitor for anything that looks weird. And to get rid of that single point of failure, you build in redundancy. So let's get to the specific. What does that actually look like? Well, you can add validation checkpoints so agents are basically double checking each other's work. You can make an AI output a confidence score, and if it's not sure about something, it gets flagged. For really high risk stuff, like moving a bunch of money, you absolutely need a human to say yes. You can even build in automation circuit breakers that just stop everything if an anomaly pops up. Think about it. Any one of these could have stopped that $500,000 mistake in its tracks. All right. So, as we wrap this up, what's the big takeaway? What's the one thing you should remember? It really comes down to a whole new way of thinking about how we build these AI systems. And here is the final thought I want to leave you with. Look, it's so easy to get excited about what an AI can do. But as these systems get more and more autonomous, we have to put just as much effort into containing them when things go wrong. Because designing for containment, that's not about holding AI back. It's about making sure we can actually trust it to run safely. In the end, it's our choice. Are we building for control or are we just inviting chaos? Thank you.